everybody. Welcome to another edition of BTV News. I'm your anchor, Zach Viaux, joined as always with my esteemed co-anchor, Brandon Meyer. Brandon?
Hey.
Thank you very much, Brandon. Tonight, our new weather forecaster, Nick Snyder, is on the job. Nick?
Thanks, Zach. We are going to have tremendously scary weather coming. We have a jet stream that's very strong, producing meridional flow, which means lots of air masses are clashing, lots of temperature gradients, very strong jet streak in the upper levels, which means we're going to have the lowest barometric pressure we've ever seen in the history of the planet, down to 800 millibars. And that's going to cause tornadoes to form, strongest tornadoes we've ever seen. We're going to have to invent a new category of tornadoes. EF6 tornadoes are going to form all across the country. We're going to have strong hurricanes from this, the strongest hurricanes we've ever seen, Category 6 hurricanes, which aren't even a real thing either. We're going to have to invent a new category of hurricanes. In short, we are all going to die.
Hello, everybody. Welcome back to another episode of BTV Nerd Night. I am your host, Zach Viaux, joined as always with my co-host, Brandon Meyer.
Hi.
The people that make this all possible are producer Mike Maisel, as well as our executive producer, Brendan Mitchell, as well as a new addition to the crew.
Hannah Goodall, right?
Yeah.
She did good job setting up.
Yes.
Also, if you like our content, make sure you like and subscribe. We're almost at 1,000 followers, and once we hit 1,000, I'll do a face reveal. I know you guys are looking for that.
True.
It's going to be great.
It's going to be very good.
Mm-hmm. Also,
Tonight.
Social media. Sorry to interrupt a bit. Social media, all at Bearcast Media. Follow it. Follow it. Follow it. Follow it. Yeah.
Please do. It makes us feel better about ourselves.
Yeah, I have very low self-esteem.
Anyway, tonight we have special guest, Nick Snyder, here with us. Nick?
Hi, Zach. How's it going?
It's going pretty well. You know, glad that we're not actually going to be dying from
of course, yeah.
EF6.
EF6. There's not actually no such thing as EF6. It goes as high as EF5. But
I'm excited to learn more about tornadoes and the like.
Crazy. So tell us why are you this weather guy? Why did we start this weather intro? What's up?
Well, I am a forecaster at WRUB, which is the student-run television station in Athens, Ohio. And I basically do the weather there about once a week. I'm a meteorology major, and I'm just the biggest weather geek ever, as you can see by this shirt too. But yeah,
I can buy a shirt that says I'm a nerd about weather. What makes you such a nerd about weather?
Because I can get what this shirt I can understand what this shirt means.
Oh, really?
Okay.
Yes.
So it says every Supercell needs its cape. So
Yes.
what does that exactly mean?
Well, have you ever heard the term like every superhero needs his cape, right?
Yeah.
So it's kind of like that. In essence, this is a weather pun too, where CAPE stands for Convective Available Potential Energy. So
Okay.
yeah, it's a measure of instability, and of course you need
that joke.
unstable air to create supercells. So it's a double pun in a sort of way.
Double pun.
Yeah.
Like a double rainbow?
Those words.
I understand none of that. I tried looking up anything about weather, and it was just like tornadoes are cool. So people probably saying like meteorology, what do you do? Like, because it has to be more complicated than what people would see, right?
Oh, definitely. It's a lot of math, a lot of physics, and if you want to go into the field, you definitely have to like math and like doing science and all that stuff. Because I mean, right now, I'm in differential equations. I'm in physics too.
Oh man.
I'm in my last math and last physics finally, but yeah, it's a lot. It's a lot of math and science. Pretty complicated, but if you like it enough, it won't bother you too much, and it's just a pretty great field to go into in general. I really do enjoy it.
I'm gonna be honest. I would have never expected that from meteorology. Honestly, it makes
Really?
sense. It's a science.
Yeah, for sure. I mean,
But
yeah.
like, I would have never been like, oh, like Diffie Q and stuff like that.
No
Yeah.
way.
Huh.
What got you on this this hard on for weather?
Uh,
We were told it was since a very young age. So.
Yeah, ever since I was really 5, we had a big storm come through when I was 5 or 6. And ever since that storm came through, it's always just been...
You were struck by lightning and it gave you
Well,
powers.
yeah, pretty much.
Are you
but
Shazam?
no.
He's more like the Flash, I'd say, but with the weather.
that's probably true.
I did run in high school, so I could be the Flash, actually.
You'll get there.
One of these days.
Yeah, maybe. Yeah, no, but ever since that storm kind of went through, it's always been really interesting to me, and I just have been fascinated by that. And really, like, when I was 11, I visited the TV station for the first time. And that's what kind of fixated me on the broadcast side of meteorology. And there's other fields you can go into it too, but do want to go into the broadcast side of it.
Really?
Yeah.
I mean, those are the people that get all the fame, right?
For sure. I mean, you get the face for it. The camera loves you, dude. I mean, but like, I guess that begs the question, because you're talking about the broadcast form. What's like the other form that people don't see? I guess?
There's multiple jobs you can do. Private sector is a big thing. Like power companies hire a bunch of meteorologists to work.
Okay.
To forecast for maintenance on the power lines or where to put power lines even. And there's also government sector, which would be the National Weather Service or the Storm Prediction Center or the National NCEP. I'm not exactly. I don't remember what the acronym is, but yeah. And they issue all the watches and warnings and advisories and stuff like that for the TV people to get the word out and let the public know. So a lot of different fields you can go into.
Do the broadcasters still do their own work though too?
Yeah, the broadcasters do make their own forecasts. They just don't issue the watches and warnings.
Huh.
Yeah.
That's really cool.
So how does one do a forecast? Do they like take a cauldron and throw in some rainwater, blood of a frog?
Well, it's actually based on current observations that you're seeing now. And you plug them into these equations. You don't have to do this manually anymore. We have supercomputers that compute the equations for us. And they output temperatures, humidity, upper air charts, which is really technical, and I could get into later. But yeah.
Okay.
Temperatures, humidity, gives guidance, and usually you just average all those out, and that's what you get in the output. Okay. Some people have different methods and use different models, but that's the way I typically forecast.
Yeah, I've always wondered about that because you always see like the 5-day forecast, and I'm always sitting there like, how do they like get that down?
Yeah, and trust me, you can never take like a 7-day, pretty much anything longer than 5 days with a grain of salt, because you really don't know what it's going to be. Because one model could say in one run, could say that you're going to get 2 feet of snow in the next 7 days, and then the next run you're just going to have sunny skies and blue. It's basically too uncertain past 7 days. That's why we typically don't go past 7 days on those forecasts.
That sounds like Cincinnati for you, though.
Yeah, all of Ohio, generally.
We kind of just glossed over. You said you do forecasting.
Yeah.
Like yourself, you do forecasting?
Mm-hmm. That's what we're taking now. Part of the curriculum is forecasting. So I'm just learning how to forecast now. And I never realized how actually tough it is, because it is really tough. And you can see, for instance, like you have a storm, you're in these weird zones here, especially in southern Ohio, where the low pressures track, and there's different areas of warmer air and cooler air and all that. So if it's in the wintertime, for example, and there's a big winter storm coming up, and it takes a certain track, you guys could see a foot of snow, moves literally a half a mile down south. You guys could only see 2 inches of snow. If it moves like a mile up north, you could see all rain. Or if it's like you could see an ice storm. It just depends on, it's this little thin line of where the rain and snow. Is that just
Cincinnati, or is that like most places?
That's pretty much everywhere across the United States, just depending on the way the storm travels.
Tell me why. Why is Cincinnati so fucky?
Cincinnati's...
Master, tell me. Weather wizard! Tell me the answers.
Well, the typical storm track usually is from, well, at least the ones that affect Ohio, typically with the winter stuff, typically comes from Texas, up from the Gulf of Mexico, and just rides up.
We need a wall.
The Ohio River.
Right in front of Texas to block all the weather.
Trump's building it, actually.
For the weather, actually.
For the weather, it's not for the
He's not
Mexicans.
racist. It's for the
it's
weather.
for the weather, of
It's
course.
for the weather, everyone.
Yeah.
Okay.
But that is really weird. So it comes up from the Gulf?
Comes up from the Gulf, typically. Depends on the way the jet stream. Everything kind of is affected by the jet stream. And jet stream's upper level at about, it depends on like how warm or cool the air. If it's warmer, it's at higher levels. If it's cooler, it's at lower levels. Okay. And it's just a belt of strong winds driven by temperature gradients. And it separates like polar air masses from like tropical air masses.
What?
And that is the way, that's basically storm systems like to ride that thing, because it's just such a high energy driven belt of winds.
It probably just makes it easier to go that way too,
exactly.
because it just carries it. Okay.
And if you have if you ever fly in a plane and you fly through one of those things, especially when you have a really strong portion of it, you can get to where you're going a lot quicker than. But typically you'd have to be flying from west to east.
So
if you fly into it, you're going to be dealing with a lot of turbulence issues and stuff like that.
So is it like that scene from Finding Nemo where they're like under the water and they're going through that jet stream but in the air?
Pretty much.
Really?
Yeah, it's a river of air. Yeah.
Nice.
It's like a high belt of really strong winds, and
That's
it can.
so cool.
It gets stronger in some places, it gets weaker in other places. But that's the way that really drives our weather.
Well, how like strong is that? Like,
oh my, it's
so like if I like jumped out of an airplane, would it like send me flying, or
Could get
say I
up
don't say I don't die right away?
It could get up over 1,000 knots. It's a really strong wind.
1,000 knots.
There's
Was that in miles per hour? Because I'm not a sailor.
I can't convert it off the top
Dude,
of my head.
okay,
What-
I'll tell
it's-
you from my own experience. I remember something that
Zach
like
the sailor.
Hey, I did a lot of sailing reading the other day. Anyway, like apparently like an old galleon like that they would use back in the good old days went like 13 knots.
To 1,000 knots.
That's like
A lot.
It's very, very strong winds, and it helps when there's no friction, because friction you get with the surface kind of thing, and that slows down the winds at the surface, like with buildings and the ground. Yeah,
1,000 knots. We were being
Wow.
told is over 1,000 miles per hour.
yeah,
Oh
it's
my
really
God.
fast.
So
wind,
I
and
would
it could-
I would probably just die if
Oh,
Like I feel like that wind would just.
no, yeah,
oh,
you
I
would-
mean, even then, you
24
wouldn't be able to
probably?
breathe up there, and
Yeah,
you
you're
just
right,
fly
yeah.
out. So yeah, but no. The
Wow.
winds in the jet stream are very strong. It varies basically by gradient. So if there's a stronger temperature gradient, the winds get a lot stronger due to the pressure gradient force, which is just winds flowing from high pressure to low pressure.
Yeah.
Winds naturally flow from high pressure to low pressure.
That was
So
gonna
when
be
you
my
have
next question, yeah.
stronger gradients, that's when the jet stream
Okay.
is a lot stronger. You get jet streaks, which develop low pressures, and troughs and ridges and stuff, which all develop low
Okay.
pressures and high pressures
Yeah,
and stuff like
Because
that.
I was wondering about that because you said before it's like hot and cold air. Is that what?
Yeah.
Because how does it go that fast? Is it like
It's just driven by the pressure gradient force,
okay.
which is
So it's like when the hot air goes into the cold air, or
it's when cold air drives all weather.
We're
'cause
not
it's more
scientists
dense.
here.
yeah,
We just like smart things sometimes.
yeah.
Well, cold air drives all the weather because it's a lot more dense. So if the
Okay.
cold air wants to retreat, that's when warm air comes up. And when the cold air wants to advance forward, that's when you get cooler air coming down. It's not necessarily hot air coming into warm air. It's more so how strong the temperature and pressure gradients are. So if there's like
They're pushing each
Up
other
to the
kind of
north.
almost.
So they're pushing each other.
not necessarily. So if
Okay.
up to the north you have really cold temperatures, and down the south you have a really warm temperature, and that's a really big temperature difference
Yeah.
in a little small area. That's when you're gonna have the strongest areas of the jet stream. When you have like a say like only a 20-degree difference in a small area, it's not going to be up in the upper levels. And surface, that's a strong temperature gradient. but
How
in the
hot
upper
do those
levels-
get? Like, do like the hot air get? Like,
It's actually much cooler in the upper atmosphere. So
Yeah, that makes sense.
really, temperatures usually are in between like -20 and -30
So-
degrees Celsius.
so
up in
the hot is
atmosphere.
really just really cold, but not
the
as
hot
cold
is
as the
the
other cold.
warmer tropical airs. Upper atmosphere are typically around freezing.
Wow.
Yeah. So it all depends on.
It's
It's
relative.
all based around because you
Okay.
have as you go up, temperature and pressure tend to decrease.
So is
Yeah.
that why it's a lot faster then? Because since it's colder up there and cold air is denser, and that's why it moves so quickly.
No, it moves so quickly because
Okay.
of the lack of friction
No.
at
Okay.
the surface.
Nope.
And again, it's driven by those gradients,
Okay.
those temperature gradients. And
Alright.
when you have those really strong temperature gradients and pressure gradients, it's going to move, it's going to accelerate the wind.
All
It's
right.
going to accelerate
all
the air.
right. I got it
Yeah.
now. So, you go. Yeah.
Craziest weather formation, top of your head.
Craziest.
Like the one that you go like it's like not like your tornadoes, hurricanes. The one that you go that just never happens and it's just nuts.
the 2011 super tornado outbreak in the southern United States, which
DJ Super Tornado?
super outbreak. So it's
What?
basically it was a strong day. It was a really all the ingredients came together in just one day, and over
Where was this?
southeastern United States, Mississippi, Alabama.
Oh, the
Georgia.
shitty states.
man.
Okay.
Wow.
But no,
Love you.
Yeah.
there were over I think like 200 tornado warnings issued that day.
200.
That
Yeah.
day?
So
Yeah.
is that 200
On
like
April
touchdowns?
27th.
Like touchdowns?
No, just warnings issued.
Oh,
I'm not
okay.
sure the exact tornadoes, but it had the most cost of damage ever in the history of the country.
Oh my god.
I think it. Don't quote me on this. I'm not exactly sure, but I think it caused the most deaths in the United States history, and
Wow.
And there were a lot of strong EF4, EF5 tornadoes that touched down in the south, and that was just a crazy, crazy day. And I remember it.
And EF5 is the highest, right?
EF5 is the highest. And I
man.
remember watching it as a kid because I was so fascinated by this. I was in 6th grade just sitting and watching this. I'm like, oh, my God, this is absolutely insane.
Yeah.
I had never seen something like that. The only thing you could really compare that to was the outbreak in 73 where Xenia got that huge tornado and it just ripped through the town of Xenia, Ohio. But that's really the only thing you compare it to because nothing else comes close to that day in 2011.
So I think it's safe to assume it's because all them sinners down south, that's what they get.
Just God's
God's wrath. No, that's it's nuts. It's nuts.
It was absolutely insane. Yeah.
That's crazy. But who wins in a fight, tornado or hurricane?
I'm personally more interested in tornadoes. That's my type of thing. But actually, I think tornadoes would win because hurricanes do drop tornadoes anyway. So it's basically
it'll survive longer.
Wait. Hurricanes drop tornadoes?
Hurricanes.
Oh my God.
Hurricanes are actually
suck.
one of the most common places you could see tornadoes in the United States.
Really?
Man.
Yes.
That's crazy.
Every time there is a hurricane coming up, they will issue a tornado watch and they're not strong tornadoes. They're only like really small spin up tornadoes, and they just drop. They could just drop here, really quickly, and then just go right back up.
Okay, I was gonna say I'd be so pissed if I was in the middle of a hurricane and just a tornado comes. I'm like, what?
But the weird thing, and I'm not sure about this right now because I haven't had a lot of the upper level classes yet. But the weird thing about hurricanes, the main ingredient that is like needed to form tornadoes will tear apart a hurricane. So this is something I have not learned yet, and I actually do want to learn more why tornadoes are so common in hurricanes.
Okay.
Because if you get strong low-level shear, which is the main ingredient, which is just veering of winds with changing in wind speed and direction as you go up, and you have strong low-level shear of that, which, again, I just said that, but that'll just rip apart a hurricane completely. So I'm not exactly sure why tornadoes are so common in hurricanes, but it's something I definitely want to do research on in the future.
That's pretty crazy.
Yeah.
Do you do research now? Like,
I did a small research project, but it was just for my observations class. So it was just researching the observations taken on Hurricane Sandy. It was just it was a minor thing. It wasn't even that big of a deal.
Yeah.
But yeah.
Aren't you going storm chasing?
I am going storm chasing this May. It's going to be. I'm absolutely. That is going to be the highlight of my summer. Definitely.
It sounds like so much fun.
Oh, yeah.
What exactly is the purpose of storm chasing, though?
Well, the main reason most people go is to kind of record observations inside tornadoes. So people are
inside tornadoes.
People are not going to actually be inside tornadoes, but they deploy.
They haul bricks in the backpack and run. I'm going into a tornado.
No, they deploy pods in the path of the tornado, and when the tornado comes over, the pods are anchored to the ground, so it's not going to go up in the air with the updraft.
Just wasting good drill pods.
God. But no, they take observations for them, and the main goal of this is to see why some storms produce tornadoes and others don't, because that's something not even the most advanced scientists don't even know that, because there's so many variables going into all the turbulence at the surface, all the shear, all of the ingredients. We just don't know. We can forecast a day that there will be likely tornadoes. We just don't know exactly why this storm over here produced a tornado and why this storm over here didn't produce a tornado.
And they're like virtually identical, I guess, and then it's like, what's going on?
Yeah,
pretty much.
and they're even trying this with computer simulations, and they're getting the same results. Some storms are producing.
What?
Some storms are producing in these supercomputer simulations, and other storms aren't not producing tornadoes. So we're
really
still
cool.
Not really sure why exactly we get tornadoes in some storms. And
it's kind of scary because I feel like we like to think we're technologically advanced. It's like, we don't fucking know.
I will say, though, radar has gotten so advanced to where it can detect rotation in storms really well. So when there's a tornado warning issued, typically most storms don't even drop tornadoes that are tornado warned because radar is really sensitive to seeing that rotation. So if you're under a tornado warning, you should definitely get into shelter. But if you're under a tornado warning, chances the storm's definitely rotating. So something's going to happen, and you're going to get a lot of good lead time in advance. So we're just trying to figure out, once we do figure out why some storms produce and others don't, we'll be able to issue tornado warnings 1, maybe even 2 days in advance, which would be just amazingly life-saving and really fascinating, honestly.
It's a lot better than like right when it's on top of you,
definitely.
like, hey, tornado warning.
No shit,
Get to cover.
Like,
But you get
I can hear it.
you get good lead time now, which is we've come a long way since the 70s when we first started researching this. So it's
Whoa,
gotten a lot
In
better.
the 70s when they first started doing tornadoes, the 70s when they were like, hey, you know those giant storms they're just ripping through towns? We should probably like figure those
and the
out.
the thing about that was the 1970 I forget, it was either 73 or 74, that big outbreak in the 70s that I referenced earlier. That was the main reason that got everyone interested in it, and that's when they came up with the rating scale for tornadoes, the EF scale. Or the F scale back then. The EF scale was a new one.
Okay.
Just based on different ways buildings are built. Because tornadoes are measured by damage, not necessarily wind speed. Because, of course, you can't get wind speed data from inside a tornado.
That's even scarier than what I thought, though. Like, EF5 means like...
I thought they were just like,
EF5
that's a big
means
one,
it would bring down a cinder block building, probably.
Oh,
Could rip up, like, the road off the surface of the ground.
Oh, my God.
At the strongest.
How fast is it's that got to be going, probably?
200 or over miles an hour.
I never
and even probably like 220 miles an hour, because I think EF4 can get up to 200 as well. So
I've heard stories of like pencils going through like crazy things. Is that true?
Oh, it's absolutely incredible. Which is the main reason people die in tornadoes. It's not necessarily because they're being lifted up in the strong winds. It's just all these things that are being picked up with you,
all the
smacking you.
Just get smacked.
Not to be too graphic here, but
you just fucking smack you.
It's just everything's coming at you at once, and you can die from trauma just because of all the things coming at you from that are being picked up from tornadoes. Yeah.
I never want to be in a tornado like that.
I just had a dumb thought.
Luckily, though, EF4 and EF5 tornadoes are extremely rare. Especially here in Ohio. Typically in Ohio, you only see EF0, EF1s, which are about at minimum 80 miles an hour.
So here's something I've heard, and I want to know if it's true. I've heard that like if you're in like in a hilly terrain or a place with like more elevation, and does that like stop tornadoes?
Not necessarily.
Oh, okay.
You can get tornadoes anywhere.
Oh, no.
And in fact, this is a actually cool thing that I learned last year.
Okay. There's
a thing called corner flow, and when a tornado hits, I'm gonna have a little prop here. When a tornado comes at an object right here, the friction will weaken the tornado, but when it ingests that corner flow, when it goes over the terrain, it'll actually going downhill strengthen the tornado.
Oh shit. No! I was always telling myself that to not be afraid of tornadoes.
Cincinnati. I was like, Cincinnati, there's hills, we'll be safe. No, we fucked.
Tornadoes can actually form anywhere, but
oh my God.
The 2011 outbreak down south and like all those states down there, those are all hilly states.
Oh man.
And the only reason typically you see most tornadoes, like videos of tornadoes out in the plains, people want to chase out in the plains because
it's probably safer, right?
It's a lot safer because
you
can't see anything when you have trees and hills.
Yeah.
You have wide open plains.
That makes sense.
But isn't it like more common though?
It is more common out in the plains,
like Iowa?
definitely.
Huh.
And that's due mainly to influences of the drier heat out in the desert, the cooler air coming up from Canada and the Gulf of Mexico all coming together, as well as other factors such as the low-level shear, which is the main ingredient. You must have low-level shear to create vorticity and these updrafts and create a mesocyclone in a storm, which is basically just the rotating part of the storm. Rotating updraft.
Do you think they could ever man-make, like, create a tornado?
I'm sure people have tried, but I'm not positive on that. I know people, the only thing I can think of when it comes to making tornadoes, people like take observations from like really strong tornado days. They plug them all into equations in the supercomputers, and these supercomputers kind of show like a visual view of what the storm is doing. It shows the storm from formation, the clouds
really cool.
building up, and then it shows the tornado dropping. But again, that's how we're trying to find how storms are producing and why storms aren't producing. But it's still creating those same results where you're seeing some that produce and some don't. So it's still really tough to try to figure out that.
Meteorology sounds like the scariest science because it's all about like guessing.
Yeah, you're just like, maybe this will work. I mean, like,
especially when you're on TV on the broadcast side, you'll get so much hate from people if you're wrong. People
Hey,
And
idiot! Like,
Yeah, exactly.
you were
And
wrong
even-
today. It's like, you do the math, asshole. I'm just
Yeah,
trying my
exactly.
best.
And even like if you're on air telling people about a tornado warning and like someone's TV show's on, they get mad and they will send tweets to you. They'll call you.
Oh my god!
And I've heard a lot of stories of that.
When do they show up to the station with pitchforks and torches?
I haven't seen that yet, but I'm sure eventually by the time I'm retired, I'll see it once because the way this country's going, you know.
This is my football game for a tornado warning.
Don't need. I've lived in this house. I'm dying in this
There's
house. goddamn it.
one broadcast meteorologist who actually retweets some of them to poke fun at them. There was one guy who tweeted him. He said he spelled LeBron LABRON. He said it's LeBron James time. Span, get off the air. And then he retweeted it just to make fun of him. And he said everybody wished Chris a happy or like a Merry Christmas or something like that. It was really savage. It was great.
People just do not have love for these meteorologists these days.
No.
I'm thankful, dude. I don't
No.
want to die from a friggin' tornado.
No,
Okay,
I was
but-
thankful.
You do have to realize tornadoes are extremely rare.
Okay.
Everywhere, pretty much everywhere. They're more common in the United States, typically in the central United States, but
Okay.
they're extremely rare.
Huh.
You need all the ingredients to come together and stuff. Yeah,
With like global warming, like does that have any effect? Do you think? Like,
we're not sure quite yet because the main reason for driving our weather is the jet stream.
Yeah.
And it's gradient driven. But when you're getting warming all across the board, it's going to weaken the jet stream, and it's not going to have as strong, it's not going to create as strong low pressures. As far as hurricanes, probably hurricanes are going to strengthen, I would assume. But another thing too, other people are saying we could see stronger jet streams. We're not exactly sure how it's going to affect the weather. So if you ever hear a politician saying, "Oh, all these tornadoes is because of global warming," no. And even like
how the fuck would you know that?
yeah, exactly. You're a
Yeah.
politician, or even like a stronger hurricane season.
Yeah.
Yes, it could have something to do, but we're still not even sure about that yet.
Yeah.
We're not. The only thing we do know is that ocean levels will be rising. That's going to be the main thing we do know. We're not exactly
Okay.
sure about hurricanes and tornadoes and more extreme events yet.
I am slowly thinking that meteorology is the most badass science.
Yeah. I don't know about badass.
Dude, they're
Most,
like
I don't know. It's very freaking cool. I'll give you that. I don't know. I'm not trying to have a science fight here. I'm not trying to have a science fight. I say chemistry is pretty crazy.
If someone came to me, I'm on meteorology's side.
We do have to take chemistry for it too. I
Boom.
have to do that next year.
Yeah, I'm sure you know like chemistry is involved.
Only one class, so it's not too bad. Mainly physics and
Yeah.
the calculus and differential equations that we need to know.
What is one of the most interesting things that you have come across, like in all of your studies so far with meteorology?
Most interesting thing,
Yeah.
lake effect snow is the most interesting. Have you ever heard?
Oh,
you
it's
probably
nuts. Yeah,
haven't
Northern Ohio. It's
heard
like
of it.
it's
And I'm from Cleveland.
dumped on.
I haven't heard of this.
So I'm from Cleveland, so we get this all the time. It is the coolest thing. It's the hardest thing to forecast ever too. But it's the coolest thing. It is when basically you get a really cold air mass
Okay.
go over a large body of water like Lake Erie up in northern Ohio.
Yeah, yeah.
And the winds dry like between the warm body of water and the cool air, you get rapidly intensing instability, and you get lots of evaporation
Oh man.
over one area, and it'll go over higher terrain, and you can get snowfall rates of up to 4 or 5 inches an hour. And 2014 Buffalo had an event like this. They got 8 feet of snow from
I
this.
think I
It
remember
was
that.
Jesus.
absolutely insane. That is the coolest thing I've ever come across,
That
and
is
I
just
really
so
cool.
much.
I
Snow.
really want to look more into that because that's just that. I'm a snow lover personally, and
Yeah.
I just love it. It just totally fascinating. You could get
Huh.
thunder snow from this, which is
Thunder
Thunder
snow.
That's my new
Definitely.
metal album, Thunder Snow.
What?
no, yeah. You can get instability that's so strong, and the clouds can reach such high levels where you can get polarity between the water droplets in the lower levels of the clouds and the ice crystals in the upper level clouds. That's what creates lightning. So you can actually see lightning and thunder with snow.
Oh.
I have seen in like video
That's
games and stuff, so
awesome.
this might not be accurate. Can you have lightning and sandstorms?
Yeah, and you can have lightning and volcanic eruptions too.
What?
When I was reading about my stuff, it was like cool weather stuff. Volcanoes create thunderstorms.
Mhm.
That's nuts. And especially in a sandstorm, like how would that?
How did that happen?
It's polarity between the molecules of what's in what's in like the condensation nuclei, which is just what water attaches to condense in clouds. So basically, when you have ice crystals that are negatively charged up at the top, don't quote me on this because I'm a little fuzzy on this.
All right.
It's
Write
either
this down,
positively
boys. Write it
charged
down.
or negatively charged. But one of them's positive and one of them's negative.
Yeah.
And you get polarity and you get the electric spark. And that creates lightning.
That's pretty nuts.
That is awesome. A sandstorm, lightning storm.
Yeah.
It's weird to think though because it's like you think like weather, especially something like that much like.
And actually, sandstorms would be more likely to produce clouds because you have a lot of sand particles in the air, and you need things for water to attach on for it to condense. So the way clouds form, water comes from the surface, and as it goes up, it cools, right?
Okay.
And so when it hits a certain level to a point of saturation, which is where the environmental temperature is equal to the temperature at which it can hold the most water, because warmer air holds more water than cooler air.
Okay.
So when you have warmer air and you have dew points in the 60s, for instance, which is the temperature at which it can hold the maximum amount of water.
All right.
When it cools to that point, that's when you start getting clouds. And if you have really unstable air, your lapse rate, which is the rate the air cools as it goes up, you just keep building and building and building until you reach all the way to the top of the troposphere and into the stratosphere. And that's when you get thunderstorms and towering cumulonimbus clouds and stuff like that.
So those are the giant clouds.
Giant vertical clouds are typically thunderstorms. You can also see nimbostratus clouds, which are the flat ones, kind of low ones that produce rain. But typically, when you're getting not typically, always when you're getting thunderstorms, you get these. You have a either conditionally unstable air mass or an absolutely unstable air mass, and you have these clouds building and building and building until they reach the top of the lowest level of the atmosphere. And some thunderstorms updrafts are so strong to where the tops will overshoot the top of the troposphere and go into the stratosphere.
What happens when they do that?
You get what's called an overshooting top. So when you have cumulonimbus clouds, they go up and up and up and up, and then it flattens out into an anvil cloud. And then when the momentum is really strong, you'll get a little peak of the cumulonimbus cloud over the anvil cloud, and that's what's called an overshooting top. And that's when you typically see hail in thunderstorms or, of course, tornadoes when you have that low-level shear going on.
That is awesome.
So what stops clouds from going into space?
As you reach the top of the troposphere, in the stratosphere, air warms as it goes up.
Okay.
So warm air rises.
Yeah.
So when you have air that's warmer than your surrounding environment, it's going to continue to rise. But when it starts warming as it goes up, it's going to become cooler than the surrounding environment. So it's just going to stop right there.
It's condensing.
That's so cool. Because you said it's an anvil cloud, right?
Yes, anvil
So
cloud.
does it just hit that like atmosphere level and
it flattens out.
That's
and when
awesome.
And if the updraft's so strong, it will peak into the stratosphere.
Wow.
That is crazy.
I wonder what that. Are there like pictures of that?
Oh yeah, you can find pictures.
There's
of
got to
that.
be pictures.
Just look up overshooting top. You could see pictures of that
That's
anywhere.
so cool.
It's pretty common in thunderstorms.
Huh.
Yeah. Oh, there we go. We have some.
We got some. That is just sweet.
That is awesome.
That's not necessarily an overshooting top.
Young Jamie in there.
Wait. If you can go to the next one. Next one right next to that. Oh, sorry, I'm pointing at the television.
Yeah.
If you go to the image that was right next to the one you just had open. Yeah, that one.
Oh my.
See those little
It's
see that little
beautiful.
peak right there? Right
Yeah.
there. That is an overshooting top right there. That's the cloud actually going into the stratosphere because it's carried by the strong momentum.
Awesome. I don't know why I find that so cool.
No, it's pretty freaking sweet.
It's just like it stops right there, and then it's like, oh, you're so powerful, you've reached above the cloud.
I bet you those clouds get cocky. They're like, I'm a god amongst clouds.
The rest of them are like, you'll be gone soon.
Eventually the downdraft will cut into it, and that's how storms fade. When you get downdrafts that are so strong, downdraft is where the rain falls.
Yeah.
Okay.
When you get downdrafts that are so strong, it'll eventually just completely undercut the updraft, which is the energy feeding into it, and it'll just cut it off, and it'll just die, and you'll get orphan anvils. So you only have that little top cloud with none of the bottom stuff. And you could see rain. You could still see rain from these until they just eventually fade out. Yeah.
Wild. Storms.
people always just like basically take storms and like lightning and tornadoes and stuff as like a sign of bad like omens, I guess. I feel like that is it a healthy planet that has all these storms? Like, 'cause that's been happening forever, right? Like,
Definitely, it is a healthy planet because again, when you have it's just natural in our atmosphere. That's how it works. Of course, you never want a tornado to hit you, but it's just
happens.
how it's a natural order of the atmosphere. Yeah, and basically that's just how it works. And you get tornadoes are very rare because you need that low level veering of the winds to actually
the perfect situation
to get a tornado.
perfect storm.
And it's really tough to even learn how to. Again, we don't even know how to forecast these in 1 to 2 days out. We know like days where we could see tornadoes in a broad area, but we can't say in Cincinnati tomorrow there's going to be a tornado because we don't know yet.
Yeah, crazy.
It's too complicated. So many variables that we haven't figured out yet.
And the jet stream changes, right? Doesn't it? Like
the jet stream changes all the time.
Oh no!
And
just more variability.
But we've definitely learned how to. We know how to forecast jet stream because it's basically only two variables, which is the gradient and the temperature gradient and the pressure gradient.
Okay.
And you
can
get
that down.
Yeah. You can get the stronger jet streaks, which are areas of really strong jet stream winds.
Oh man.
In these entrance and exits region, the right entrance region of that jet streak, and the left entrance region or left exit, region of the jet streak, you'll see low pressures form, and when you get stronger jet streaks, you'll typically see stronger low pressures. Or even if you have strong troughs and ridges, which troughs are deep levels of cold air coming down from the North Pole, polar air mass, which you ever heard the term polar vortex? It's actually weakening of the polar vortex. Because it's when you have a strong polar vortex, all the like really Arctic air is going to be bottled up. When you have a weakening of the polar vortex, it's going to slowly come on down in the continental United States, and it'll drive stronger storms when you have those stronger temperature gradients and those troughs and ridges. Now you could get zonal flow, which is basically the jet streams going just east to west, and you don't see many troughs and ridges in those. And typically those you'll see sunny weather, calm weather, nice weather, basically all across the continental United States. So, yeah.
Sweet. Here's something I just thought of is all the time whenever I'm like on weather.com looking at the forecast, see if I can go to the beach this day, there's always like, I always notice the weather going from like left to right.
Yes.
Is there a reason for that?
Jet stream. Jet stream
okay.
always goes east to
jet stream
is
always the answer.
Yes. Okay, so it always goes that direction.
Always goes from west to east. And
why did Karen leave me?
Hurricane.
Jet stream.
There's our one Karen joke.
Please, Karen.
The only exception to this would be hurricanes. Hurricanes I've never seen a hurricane move from east to west until it makes the turn, but hurricanes usually come off the coast of Africa and move from east to west.
Really?
Yeah.
So why does Africa hate us so much?
I can tell you.
The weather, I mean.
That's the typical hurricane track, though. When you'll get a cluster of like weak thunderstorms off the coast of Africa, and it'll go over those warm ocean waters. You have weak low-level shear to not tear those apart, keep those thunderstorms clustered together. They'll form into a tropical depression. Keep ingesting those warmer waters. It'll definitely begin to form into a tropical storm, and then you get a hurricane. So, hurricanes typically move from east to west, and then once they hit a certain point where they encounter
land,
not necessarily land, but other like non-tropical systems, they'll make that turn and then go off to the east.
They're like, nope, I don't like this area.
Exactly. Because when you encounter a surface high pressure or a surface low pressure, especially surface high pressure, storms don't like high pressure because they need to rise. You need lift to create storms.
All right.
So they want to go away from the high pressure. They'll turn to make that turn. And hurricanes don't typically like post-tropical systems as well. And you also get that wind from that, or not post-tropical systems, mid-latitude systems. And when those mid-latitude systems come, you'll get wind from those to push those out as well. So it depends on if you have all the right ingredients, the hurricane will make the turn and impact U.S. land, like we saw with Hurricane Florence, for example.
Okay.
Made impact on North Carolina, but once it encountered that terrain, different terrain, it just cut it off. And that's why we typically don't see hurricanes in Ohio. The only exception to this would be Hurricane Sandy, when one of the most outer rain bands of the hurricane actually made it into northeastern Ohio.
Was that when the wind was crazy?
Yeah, there was a huge windstorm. I remember when I was younger. Was
that was in 2012?
Yeah,
Sandy. Yeah,
I was. Like that was.
But we didn't see it. You didn't necessarily see it down here, but I think it made it into very far northeastern Ohio before it merged with a different system. It became post-tropical.
Okay. I kind of remember like a big windstorm that was a remnant of some hurricane.
I remember being a moron and like the trees are shaking all over the place.
That might have been Hurricane Ike, actually.
I think that's what it was. Ike.
It was and it was weird with Ike is since it lost all its moisture from going over land, it was a dry storm, so it was just wind.
What?
You didn't see any rain.
Yeah.
Because it lost all of its moisture after being cut off from the moisture, but it actually stayed relatively strong, which is an outlier, and I'm not sure exactly why yet, but I could figure that out in the future.
Meteorology's so cool.
Like, we don't fucking know why, but that was nuts.
I personally don't know why, but
sure
definitely
some people do.
I'm sure people do. Hurricanes are not really.
Who's the Michael Jordan of
meteorology?
There's a couple of them. There's James Spann, who's down in Birmingham, Alabama. And there's Tom Skilling, who's in Chicago, who I'm actually hopefully going to intern with next summer.
With him, particularly?
Yes. Mm-hmm. And
is he going to dunk on you? Tornadoes! But like, what makes them so, like,
the people in their markets just love them. And that's just in broadcast meteorology. There's Dr. Fujita, who he's the tornado rating scale is named after him.
Yeah, I was wondering what that was for.
He's the one who created the tornado rating system. Excuse me. He's a genius. He's the one, basically the reason why we know so much about tornadoes as we do today.
Really?
And yeah,
where's he based?
He's dead right now.
Oh, okay.
But
based in hell.
No,
he's probably a good guy.
He was
heaven.
He was a meteorology professor at Penn State, and he did all this research on tornadoes. And basically, he's the one he's the reason why we know so much about tornadoes that we do today. And there's Greg Forbes, who's actually a graduate student working. He works on the Weather Channel.
Okay.
Yeah, Dr. Greg Forbes. He's a really good guy. And there are a lot of people in the National Weather. The National Weather Service really, they work. Pretty much everyone in the National Weather Service is amazing. They work hours, even when the government was shut down too. They weren't making any money, but they still had to work.
Yeah.
And because
you never know when a tornado's gonna hit.
You never knew what's gonna happen. You still need someone to forecast the weather and issue watches, warnings, and advisories.
Unsung
they do all
heroes.
that. Yeah, the people at the National Weather Service are great, and you should, when you get a watch or a warning, you should also always listen to their advice, because they know what they're talking about. They're amazing over there at the Weather Service.
Make sure you listen to the unsung heroes at the National Weather Service.
National Weather Service in Wilmington, down in southwestern Ohio, by the way.
Yeah. Yeah. Are there any phonies? Any guys you're like, that guy just sucks. He doesn't know what he's talking about.
I couldn't think of any off the top of my head right now, but I'm sure there are some. A lot of them probably in the broadcast field who don't have meteorology degrees.
They're just faking it.
They just probably
steal from other people.
Copy forecasts from online, or just look at models and do that kind of thing. But
don't do their own forecasting.
They don't do their own forecasting, but it's typically on the broadcast side. And there's nothing wrong with not having a meteorology degree, but you need to know your stuff to actually be able to do it right and do it well and be accurate. Stuff like that.
We talked about, like, before this, we were talking about, like, early meteorology.
Mm-hmm.
Benjamin Franklin's book, the Almanac.
He's the first person in United States history to ever record observations. Ever record observations.
Like full scientific observations.
Yeah, like cloud coverage, temperature, high temperatures, low temperatures, humidity readings, etc. He was the first one to ever take observations.
How useful was that actually? Was it useful, or was
it
just kind of like
It was useful kind of in the beginning stage of learning how to forecast, but we didn't really necessarily understand most of this stuff till the early 1800s, when the National Weather Service actually founded.
Okay.
So.
Okay.
And that's where all of our. You ever see on TV when the meteorologist has like the highs, lows, and records.
Yeah.
Yeah.
Those records date all the way back to the early 1800s.
Wow.
Holy shit.
So
That's awesome.
yeah, we've been keeping records for almost 200 years.
The ancient order of the meteorologists.
Honestly, I
The
keep
Illuminati
thinking
of
meteorologists
weather.
are wizards more and more.
They're definitely wizards, and
they're just like they're like peering into the future, like this is what will be coming.
that's a tornado, Harry.
One day, this was actually cool. When I was in Chicago interviewing for this internship position, we were looking at this this parameter on a model called Supercell composite, and it's a range from like 1 to 10.
Okay.
And it had values of in southern Indiana for 2 days in advance of like 7 or 8, which is really high on the spectrum. And then I remember the day I left Chicago, which was 2 days later, we did have a couple tornado warnings in Indiana and Ohio.
Oh man.
It was a pretty cool day. And yeah.
That's got to be really cool.
Mm-hmm. Looking at those models, it's pretty interesting what you can see, and you can some of these models you could take a slice of the atmosphere and you can look into it as if I was looking into it like right into the camera I am right now.
Oh.
Yeah,
R
it's pretty fascinating.
R/ things cut in half.
Pretty much, yeah. It's called quick plug tropicaltidbits.com. It's really interesting. Really interesting. Yeah.
Okay.
Yeah.
Okay.
I like that a lot. So here's something I've been wondering about. We got all these facts and figures and all these observations we're taking.
Mm-hmm.
How do you take most of these observations? Do you have like instruments that you bring up?
There are different weather stations located all across the country.
Okay.
And we have one in Athens. You guys have a couple in Cincinnati.
Oh, okay.
And they have anemometer, which measures wind speed and direction.
Is that the little thingy with little cups on
The
it?
cups on it
Okay.
and the arrow. Yeah.
The thing with
you
the
have-
cups on it. That's a scientific term for it.
Hey, we're very smart.
Of course, you have the barometer for pressure.
Okay.
Wind speed, I should note, wind speed's measured at 10 meters of height. So 10 meters up.
How come 10 meters?
Because right at the surface, you're going to be dealing with a lot of friction, and you're not going to have very accurate information.
All right.
So the best wind,
Yes.
10 meters.
And temperatures are measured by, obviously, thermometer, which are at 2 meters up. So basically, like, right about here.
Yeah.
Um,
Why is that?
It's just easier to read,
Oh.
I'm guessing.
So it's eye level. You
Eye
idiot.
level,
And
yeah.
It's 20 feet up in the air. You
And-
what does it say?
2 meters, 2 meters, it's not going to make a difference from ground to.
Yeah.
Plus, you're not going to get any outside influence on the instrument, such as dew or
Yeah,
something that would make it seem cooler or more humid.
Mm.
Humidity is measured with a hydrometer. I think I said that right. Hydrometer, which basically it takes the exact amount of water the air can hold, and it not sure how it's calculated.
Okay.
I know I should know this. I learned it last
Failed
year,
your class.
but and I got like a 98 in the class. But I should know this. But no, it tells us the
98
relative
in the
humidity. So
class.
humidity
Don't know that one.
in percentage is totally based on how warm or cool it is outside. So if
Okay.
it's cold, and the dew point is a better measure of humidity. So the dew point is the temperature at which you've reached the maximum amount of water you can hold in that
I've always wondered what that actually
temperature.
meant.
Yeah. So that's the dew point. And when you have a temperature of, say, 64, and your dew point is 64, that's the most amount of water that 64-degree temperature can hold. And you
Okay.
can get fog. You probably will get fog from this because of the
Yeah.
because it's hit the max temperature. So that's typically how fog forms
Okay.
when you reach the dew point temperature.
And
And
is that why it? How come fog only forms in the mornings usually then too?
that's radiation fog. When you get the outgoing, when it cools in the night, we cool down to we cool down to the dew point
Okay.
temperature, and that's when we've reached that maximum amount of water you can hold. That's why we also get dew.
I'm assuming
well.
it's not like radioactive radiation.
No, it's basically
Grow a
radiation
leg.
from the sun.
Okay.
Radiation.
That makes sense.
Radiation
Just
comes
heating up
into-
the water.
comes into the earth
I figured.
from the
makes sense.
sun, and as at night comes, it leaves the earth.
Yeah.
Long wave radiation.
Be a lot
Shortwave
cooler if it was
radiation
uranium.
coming into, and outgoing radiation leaving the earth. Long wave radiation leaving the earth, and Oh, I forget what I was gonna say, but
Good.
The fogs and the dew points.
yeah,
and
fog. When you get oh yeah, that's what I was gonna say. When you have clouds at night, it'll typically be warmer because it's blocking the outgoing radiation from leaving. Or typically warmer. Did I say warmer? Yeah, I think I said warmer. When you have clouds in the night, it'll be warmer, and when it's cloudy day, it'll be cooler because it'll block the incoming radiation from the sun.
Oh.
So it's interesting like that. Yeah.
Huh. I've always had like when I was a kid actually and like really young, I always thought there were like more clouds at night. I don't know if that is factual though.
I don't.
Yeah.
I don't really think that's actual fact. It's
someone's
all
out there
dependent.
counting them.
But when I was younger, there was a brief period where I was like, oh, there's like so many clouds in the sky. That's why it turns into night because the clouds block out the sun. I'm glad I don't believe that anymore.
Yeah, it's good.
It's okay.
The clouds block out the sun. It's night. It's night, Mom. Look, I got a big clouds in the sky.
Why does the sun go down too?
He's a special child, okay? He's just special. He's growing up.
Mr. VX, your tuition's really helping. Oh my God. Oof.
Good thing he's not a meteorology student.
Yeah.
Honestly.
That's true.
Or an astronomy student too.
Where are some like? Because I feel like in the Midwest we have some like unpredictable weather.
Definitely.
But is there like any places that are like the weather's just so extreme that you're like, what's going on here?
West Coast, up near Seattle, when you have those mountains,
Yeah.
you get those, because when you're in the upper elevation, you're gonna get much cooler temperatures. So it could be a really pain in the ass forecast up in Seattle,
I bet.
especially like further inland in Seattle.
Oh, man.
When you have these rain systems coming in, because it never will snow in Seattle because they're right by the Pacific Ocean. The Pacific Ocean's keeping them warm enough always for rain.
Huh.
But you go inland into those mountains, you could have snow in this pocket, rain in this pocket. One place could get 4 feet of snow, another place could get an inch of snow in just these little areas.
That's why Kurt Cobain was so sad. He was a meteorologist.
Definitely. And
oh man.
along the Great Lakes too, when you get the lake effect snow, because that's the hardest thing. You don't know exactly where the squalls are going to set up, and you can have this narrow band of just 2 feet of snow, and then everywhere else will just get an inch if they're lucky, you know?
God, that must be a nightmare to forecast up there.
It is absolutely insane forecasting lake effect snow.
But it does rain a lot more though over there, right? Like
up in
like Seattle.
In Seattle definitely, but up in northeastern Ohio typically not. Same type of climate, just we get the lake effect up there.
Okay.
Oh yeah, we had one forecast back in November the National Weather Service in Cleveland issued. They had a low-end spectrum, a high-end spectrum, and an average. This city called Elyria, which is near Cleveland. The low end, they had 1 inch. The high end, they had 7 inches, and the mean was like 4. So basically, they were forecasting 1 to 7 inches of snow for Elyria. Snow is really tough to forecast for.
Yeah.
Yeah. And
why is that?
it's just the way it's set up, because the way you need, the amount of ingredients you need for snow to happen is actually pretty crazy. You need, of course, below freezing. If not below freezing, you need your wet bulb temperature, which is the temperature after water's evaporated,
Okay.
to be below freezing. And when you're right on that line of like rain and snow, like talking about Seattle, you don't know exactly. It's really hard to narrow down where the pockets of snow will be. And when you're dealing with lake effect, you don't know exactly where the strongest updrafts are going to be to create these powerful squalls. So it's just snow is one of the hardest things to forecast for.
Man.
Yeah.
Like, dude, they are wizards. Meteorologists are wizards.
Okay, because they're just guessing. They're like, I don't fucking know.
Well, they do know. They know better than anyone else.
I mean, yeah, for sure. But like,
But they're like,
half it's like we're pretty sure, but maybe something else.
1 inch, 7 inch.
There are definitely different methods used
There's
for
a dick joke
forecasting.
in there.
Oh,
somewhere,
really?
But
Yeah.
Oh, okay. For some reason, I was like,
You can combine methods, and that's the way you could get the most accurate
okay.
information. So the numerical models, which is the models we look at, and averaging those out. But you can also look at past events. And looking at past events could be better for forecasting certain events than others. So, for instance, lake effect snow. Well, lake effect snow squalls typically set up along the eastern side of the lakes.
okay.
So the west side, you can confidently say, oh, you're probably not going to get all that much.
Okay.
On the east side, you can say, well, yeah, you're probably going to get a lot. So, and even looking at severe weather, when you have high Cape values, when you have high low-level shear, you could say, okay, this general broad area, these certain states have risks of seeing tornadoes that day, or even flooding events. You have the models guidance are showing high values of precipitable water, which would be the amount of water that's in the air translated in inches followed of rain. So if every drop of water that was in the air due to the humidity fell out of the air and fell as rain, that would be the amount of inches of rain that would fall. So when you have high model, confident model guidance suggesting really high precipitable water values, and on top of that you're melting snow, and you're dealing with a lot of wet grounds, you could typically say, okay, this is going to be a big flood event. And
that's a lot of variables.
The River Forecast Center forecast for that. So it definitely different methods of forecasting, but the best way to forecast typically is combining the numerical models with some of the older methods of looking at past events, or even persistence forecasting,
really cool.
where it's saying it was 86 on Tuesday, it was 87 today, which means it's going to be 88 tomorrow. Something, stuff like that.
Yeah.
Combining all those things is really definitely the more tools you have, the better forecast you're going to get typically. And the higher what's the word I'm looking for? The more correlation between the models.
Okay.
Like if all the models are saying the very near temperatures, like one model is saying the high is going to be 61 tomorrow.
Okay.
Another model is saying it's going to be 63. Another one's saying it's going to be 62. You can confidently say, okay, my highs are going to be in the low 60s tomorrow.
All right.
Because you have high confidence between all the models.
I like that. High confidence.
Yeah. I mean, it seems like pretty scientific and whatnot. There's a lot of stuff going in there.
Dude, there's so many variables.
Supercomputers, equations, stuff like that.
I haven't even gotten to like lapse rates and theta E, which is you have to. That's with all the math, and that's the stuff I don't know yet. Which is I'm gonna learn in dynamic theta E.
Theta E, the weather fraternity.
That'd be a really good weather fraternity.
I can't remember what theta E is. It's something that has to do with isotropic heights, which is just looking at different variables as you go up in different pressure levels.
Awesome.
So yeah, you're looking at pressure, you're looking at temperature, you're looking at lapse rates, you're looking at cape, you're looking at shear, you're looking at wind, speed, direction, just all these variables combined to these integrals and diffie-qs and derivatives, and it's challenging. But luckily, the computers are doing that for us now.
So this must make it so much more frustrating when some just hilljack tweets at you.
Yeah.
I'm trying to watch Labran James.
Yes.
Like, hey, they put a lot of work into.
And you see people complaining all the time, like the broadcast meteorologists complaining. If you try forecasting for a day and see how hard it is, because it is really hard to forecast.
Seems like it.
It is. It's a tough
lot
job.
Of variables, and then even at the end of the day, when you're done with your forecast, you're like, there's some variability. This
and it also changes throughout the day too. So you're like, okay,
you could totally bomb a forecast. I've definitely bombed many forecasts before.
Really? People get mad at you on campus.
Lucky for me, nobody watched. Hopefully,
there's probably one guy out there. Watch his show. Watch his Weather Channel.
It's a PBS station in southeastern Ohio.
Still
One, it's a very sparsely populated area. Two, who really watches PBS? I hope I don't get fired. But even though I'm not making any money from this, but
hey, you're safe here. They won't find you.
Yeah.
No one watches this either.
Atish and Allison don't watch this. I didn't mean it, Atish. Yeah, but that's something I'm not really looking forward to, because you have to learn how to get thick skin in this field, because you'll get your head ripped off by some of these people if you totally bomb a forecast.
Really?
And no one's gonna ever have a perfect forecast. Yeah. It's impossible.
Yeah.
But you can always bomb a forecast, and everyone bombs a forecast.
So what are the expectations in the field then, like when they're looking for forecasters?
Just as long. If you say it's going to rain, like if you say there's anything really above a 30% chance of rain, then you should expect it to rain. You should be within like 3 or 4 degrees for the high, maybe even 5 degrees for the high.
Damn.
Same thing for the low. And actually, the temperatures are the easiest things to forecast for because you're just averaging those out from the models. But once you get to winds and precipitation, that's where it gets tough.
Luckily, people probably don't look at that unless they're like.
That's what I look
Well,
at.
you definitely do look at the precipitation because you want to know if it's going to rain tomorrow or not.
Yeah.
Oh, okay,
Yeah.
okay, never mind. Yeah.
So that's the challenging part, and we're getting better at that. We have models that tell us that give us percentages for rain now, which is nice. And it
Like
makes
percentage of
so
chance
easy.
it's going to rain.
Yeah,
Or?
some of the models will say it's going to rain. There's a 95% chance of rain at this time. There's a 60% chance of rain at this time, and another model will say something else, and that's what makes it a lot easier for forecasting for rain. And there's even more stuff I could even learn because there's jobs at the school that offer you can be the lead forecaster for the weather lab there, and you get extra forecasting training. So I'm hopefully going to look into that and kind of hone in on my forecasting skills to become the best fourcaster I can be, because that's the most important thing at the end of the day. You want to get your forecast as close to as accurate as you could possibly get it.
You want to make sure people leave the house with an umbrella or not.
Definitely. Yeah, exactly. If you say it's going to rain, it should rain.
After you graduate, do you have any eyes on any particular things you want to do, like stations or?
After I graduate, there's no particular station I do want to go to right after I graduate. But by the time
what's your end goal? Like what's
by the time
the
I'm
big
30,
leagues for you?
The time I'm 30, I want to end up in Chicago.
Chicago.
I've always loved Chicago.
Chicago's cool.
The Windy City. They probably got some good stuff going on over there.
The Windy City is actually
not the windiest place, right?
No, it's the reason it's called the Windy City is actually because politicians blow hot air out of their mouths all the time.
Oh, really?
Yeah, it has nothing to do with the weather.
Oh,
fuck me. I guess.
Every time I went up there, it was super windy, and I was like, "Yep, Windy City."
I'm sure it's kind of windy because the lake, probably, right? I don't know, maybe.
I mean, it would be windy, but it's no windier than it is typically here or up in
Really?
Cleveland or in Columbus
Okay.
or anywhere.
It probably
in the
just
United
windy
States.
sometimes, and people go, "That makes sense." And
Yeah.
they start perpetuating this lie everyone's telling us. Why, Mom?
Not to get too political here, but yeah, the reason it's called the Windy City is because they nicknamed it that because the political climate, like politicians blowing hot air out of their asses or out of their mouths and stuff like that.
That makes sense. Yeah, okay.
Huh,
That was a fun fact I learned from my friend Joey, who goes to school in Chicago. So
okay.
Yeah.
So why is Chicago your place to go?
The city's amazing. I just love that
Just
city.
love Chicago?
Plus, it's top three market, and you can make lots of money in that market. And I want to make.
It's expensive to live there.
It is expensive to live there, but
when you're making it rain, you're gonna make it rain. Am I right?
you can make
My God.
300 or more,
I hate myself.
300,000 or more in markets that big.
Wow. You are making it rain.
So hopefully I do get there by the time I'm 30. That's the end goal.
Hell yeah.
Yeah.
Pretty sweet.
Hope you do as well.
Do you have to? Is it like the kind of thing where you gotta know certain people? Or is it just like, oh, this?
You got to know certain people, and you got to have the experience and the credentials as well. Which is
does personality take into account as well? 'Cause
personality definitely.
If you're doing broadcast, you got to be
And
likable, right?
that's where your reel comes in. So you make like a demo reel,
Ooh.
and depending on if they like you or not, then they'll bring you in for an interview.
Okay.
And
You
stuff
can
like that.
bring us.
Promise
back
me,
onto it.
promise me right now, you never do cheesy memes.
Oh, I will never do that.
I saw
Have-
one on
did
Twitter
you-
the other day.
Did
It
you
was horrible.
did you guys happen to see the thing on Twitter from the TV station in Toledo
I think
where
so.
the weather's gonna be turned, right, Chris?
It's gonna be lit as hell.
Yeah.
I
What?
saw
Yeah.
it.
It was
It's
cringy.
So cringy.
It was the most cringy thing
They're
ever.
like, I'm gonna whip on over to my friend over there, and I'm
Is
just
the
like,
traffic gonna be
yeah, they said
Yeah.
it like
Yeah.
3 times.
What?
yeah.
I wanted, I was having an aneurysm,
Yeah.
while watching.
And it
this.
was-
I was just,
Man.
I will never ever. I don't care if the producer says they're gonna fire me because I will never do something like that on the air
Yeah.
because that just people will make fun of me for that, and I will just never live that down. Because
Right.
plus, that's not who I am at all.
Yeah.
That's just fake, you know.
Yeah.
I want to be as real as I can be on air. So
Well,
Especially if you're like giving people the weather.
yeah,
no,
That's
if you're giving me the
ridiculous.
weather, I'm like, stop trying to make
Especially usually when
just give me the weather. Give me the information. Stop trying to be so extra. Just give me, and that's what I want to do. I want to bring the end goal. I want to teach more of the heavier science to the people so they understand
Yeah.
more what's going on.
Yeah,
I feel like
And-
people need that.
Yeah.
for sure. People are dumb.
Yeah.
People are
And-
stupid. You should teach
oh
them.
my
Well,
God.
and because
One of my
sometimes-
quotes: "Never underestimate the stupidness of people," because
Period.
they're
Fuck them.
pretty stupid people out there.
Oh yeah.
I
That's a
know.
moron.
Who?
I don't know.
Okay. I'm just glad that we don't
Mr.
tell
Night
shitty
Clouds.
jokes on this podcast.
Never.
We would never do
Would
that.
I ever?
Yeah. But yeah. Got questions?
I'm trying to come up with stuff because we've gone over tornadoes. We've gone over hurricanes.
What's like the cool
Oh God.
grapple?
Grapple.
We're talking.
Ooh, I could
What's
go into this.
grapple?
Okay, I could go into this for hours.
Grapple.
Different precipitation types. Okay, so
Oh.
okay, so
Wait.
yeah,
Different precipitation types. So there's rain.
there's rain.
There's snow.
Mhm.
There's
Hail.
grapple.
Yes, grapple is a precipitation. I'll get to
Is
that.
it dropping like gremlins?
I'll explain it.
I have a follow-up question after this
Yes.
too.
So there's rain, snow, sleet, hail, grapple. Those are the 5 main
Who
ones.
named it grapple? That's the silliest.
I'm not sure. But if you ever think
Dr.
it is
Seuss.
hailing in the winter, you're wrong. It is not hail. Hail doesn't happen in the winter. It only happens in thunderstorms in the summertime.
Oh.
Yeah.
Okay.
Hail is a result of updrafts holding up raindrops
Okay.
and supercooled water, which is water that it has a temperature below freezing.
Okay.
Just freezes onto it, and it instantly freezes. And it just, once it gets too heavy for the updraft, it just falls, and that's falls. So you'll see hail
Okay.
in really strong thunderstorms with
Yeah.
those really strong updrafts, and you get shear. Shear is another ingredient. You get in that too. Sleet falls. This is what you typically see in the winter when it's like when there's those ice pellets and you think it's hail, but it's actually sleet.
Okay.
So sleet is
Huh.
basically it starts as snow.
All right.
It goes through a little warming layer in between the surface and the in between the surface and the upper levels.
Okay.
It goes through like a really shallow warm layer. It refreezes back into ice and it falls as these little ice pellets, and that typically happens in the winter. You get freezing rain when it starts to snow again. It goes through a deep warming layer, and then right at the surface you get freezing temperatures. So it freezes. It falls as rain, but it freezes right on contact. As soon as it hits the ground, it just freezes right on
Ooh.
contact.
Okay.
Then you get basically ice skating rinks as roads when you have these big
That's
ice
black
storms.
ice.
Yeah.
Okay.
Black ice
Oh.
is different. Black ice
What's
just
black ice?
forms from rain that's fallen, and then the cold front passes, and then it just freezes after the cold front
Okay.
passes. Freezing rain just freezes on contact.
Huh.
Snow,
That
of course, it just falls through the cold layer the whole time.
Yeah.
Grapple,
All right.
Grapple.
The granddaddy.
granddaddy. Grapple is
Yeah, grapple.
again, you may mistake this for hail as well. Have you ever seen those little white like it looks like snow, but when it hits the ground, it kind of bounces.
Yeah.
Okay.
That's grapple. So what grapple is,
Huh.
it's snow. It starts as snow, and then it falls through like a really shallow warming layer. Supercooled liquid refreezes onto it, and it creates these like little
Pellets?
ice snowball pellet kind of things. There's a picture of it right there.
Oh
Grapple.
yeah.
Yeah,
These are just Dippin' Dots.
yeah. They look exactly like Dippin' Dots. Yes, that's grapple. Did I miss anything? I got rain. Oh, just rain. You know what rain is.
Yeah.
Rain,
Water.
sleet, snow, freezing rain, and hail, and grapple.
I thought all of those. I thought the freezing rain, hail,
Who
and sleet
named
were the
it
same
grapple?
thing.
No, not at all.
I'm gonna fight that
Okay.
guy.
Not at all.
Grapple.
Hail only happens in thunderstorms during the summertime.
It's
Or in the
specifically
springtime.
The summer. Okay, spring.
Spring, summer, or fall. It doesn't
Okay.
unless you get a thunderstorm in the winter. It's not going to hail in the winter.
Because it's not gonna snow during those times, right?
Well, no, because
Okay.
when you have hail only happens in thunderstorms
Thunderstorms.
when the raindrops are being held up by the updraft.
Mhm.
Okay. Okay.
When you get sleet, again, it's just the shallow warming layer. Freezing rain is the deep warming layer, and it's just the rain freezing on contact with the ground. And then grapple is the supercooled liquid refreezing onto the snowflakes.
I love that
Yeah.
word.
Grapple.
Grapple.
Graupel. Spelled really
Grapple.
weird, too.
Yeah, it is spelled very weird.
Grapple.
Here's gonna be my follow-up question
All
as
right,
well.
yeah.
So we have those ones.
Mm-hmm.
What the fuck is acid rain?
Acid
rain.
rain.
That was when you're tripping on that shit. No, I'm kidding.
Get that good shit, baby.
Acid rain is when you get, a cloud that forms in a heavy polluted area, and the pH in the water just gets all off balance from all the stuff that's being spewed from the factories and stuff,
Ugh.
and it just turns in you get hydrogen bonding, and it creates a lower pH than 7. When you have stuff lower
Yeah.
pH, it'll fall as.
Is that basically the same thing as smog then? Just like fog, but just with pollution?
It's essentially it's close to smog. Smog is more to do with inversions, which is air warming with height. And when you have air warming with height, you're going to keep air trapped in that, and it's just not going to ever move. And when you get smog, you'll get just this stagnant air that is all polluted and stuff like that. Because when air doesn't move, it doesn't. It just stays there and keeps gathering more and more pollutants. And condensed into one area, not more spread out like typical.
Oh yeah, we didn't mention this. Brendan and Nick have been best buddies since 2nd grade.
Yeah,
It's true.
Brendan's a man.
He is the man with the plan.
The man.
Oh yeah.
This kid walked into his basically the first day into Brendan's parents' house and just opened every single window to let the weather in.
Yeah.
Apparently that's what happened. I don't remember exactly like that, but we'll go with that, I guess.
He was born to be the weatherman.
I do believe I was born to do this because I just love it so much. Yeah.
Really?
Yeah.
Sometimes you just have a calling and you just really follow it and you want to know as much as you can. And this is kind of what I want to do.
Especially for something with like meteorology where it's like there's so many things that are still to be discovered.
And if you're good at it, then you're going to be amazing because people are going to go, this guy's like knows his shit.
And you'll be well known and people will love it. And it's just a great thing.
The masses of adoring fans.
Oh, I'm not looking forward to
He's
that.
so good at the weather!
As well as the lowly tweet saying LeBron James.
LeBron James. Get off the air. It's LeBron time. Yeah.
Did you ever like... Brandon's got a question.
It's a thing within people typically because
So, weather depression, is that a thing that affects people?
I think it's more of a seasonal depression.
It's a seasonal thing because people typically people are. I personally don't study this because I'm not really into the social science, but I think it's more to do like when it's sunny out, most people are more happy, and when they're not seeing the sun and it's cold, they're gonna be inside more, and it's just gonna be.
I think it also tends to do with the amount of sun you're getting as well.
Yeah.
Because the more sun you're getting more vitamins, whatever.
Vitamin D.
Vitamin D, exactly, from the sun. And basically, when it's wintertime, you're inside, it's dark and stuff, and you're basically inside most of the time. You're not getting that sun naturally, and you just kind of feel shittier.
It makes so much sense. That's why everyone in Britain is so sad all the time.
I think it's... No, yeah, you're right.
Yeah.
Weather in England. Why is the weather in England so trash?
That's just due to the low pressures coming in from the. It's all based on what the jet stream. Again, the jet stream.
All hail the jet stream.
Yeah, that's the main controlling thing, and you typically just see a lot of variability in the jet stream. There, you typically see a lot of low pressures bringing rain and clouds into the area most of the time, and it's just a wet climate because it's an island right on the Atlantic Ocean. So you're gonna typically. It's in a very wet climate over there.
I mean, it makes sense that they were like, let's just invade everywhere else because we suck.
Honestly. Hey, India's got really good weather, and they got over there, and then there are monsoons.
Yeah.
Monsoons are actually interesting. It's
Tell us.
The monsoon, what happens with monsoons, this is more of a climatological thing. What happens with monsoons, you have this area of convergence near the equator called the intertropical convergence zone.
Okay.
And it migrates based on what the seasons. During the summer, when the Earth is tilted towards when the northern hemisphere of the Earth is tilted towards the sun, it'll migrate up north, and that's when it'll migrate down south. So they'll have their dry season. No, it'll migrate up north in the summer, and they'll have their wet season. I'm sure about that.
Are you sure about that?
Yes, I'm sure about that. It'll move up north, and right around like 23.5 degrees, they'll have their wet season. All those the convergence area of rains and thunderstorms.
Oh, man.
Then, as the Earth tilts away from as the northern hemisphere tilts away from the sun, and the southern hemisphere has their summer, it moves down south of the equator, and that's when they get their monsoons. So monsoons are very tropically driven climatological phenomenon, and it could also happen in when you're dealing with like oceans. And you have a prevailing belt of low pressures, kind of forcing basically thermally forced, and you're driving more convergence at the surface to produce rising air and rain showers.
Okay.
And then versus the winter when it's cooler and you have thermally driven high pressure, it drives away all of the rain showers and it's mainly dry.
Huh.
Yeah.
That's pretty cool.
Yeah.
Aren't there like mega storms out in the ocean? Or is that just something that lives inside my fantasy?
I think that's something that lives inside your fantasy.
I think we would
Unless
know
you're
if
talking about hurricanes, of course.
Yeah,
But
okay.
Yeah. Storms can get pretty strong. You get like when you have winter storm, when you know how New York and Boston sometimes get massive snowstorms.
Yeah.
That's basically the low pressure tracks across the United States, hits the Atlantic Ocean, gathers all this warm ocean water with it. It becomes stronger, it explodes, it bombs out as the actually that's a technical term.
Bombs out?
Yeah, bombs out.
Bombs out, bro.
It drops I think it drops 27 millibars in 24 hours or something, which is a big drop in pressure. Millibar is a measure of pressure.
Okay.
Yeah.
Okay.
And it rides up the East Coast and it gathers all this ocean moisture and it dumps so much snow on the eastern seaboard just because of.
So that's why they get like huge.
That's why they
that's
typically.
why Boston is so angry. They'll fight each other. They're like, oh, the snow is just bombing out on us.
You're offending someone right now.
Oh, definitely. Hey, Trevor. Trevor, you from Boston?
Yeah, we're looking at you, Trevor.
Ooh, look at me. I'm Trevor. My parents are in Boston. It's a very specific meme, but
Yeah.
Boston people are angry. It's okay.
Oh.
What's
Go
up,
ahead,
producer
Brendan.
question?
That's a good one. Any meteorological phenomenon?
Well, like I said, tornadoes that,
that boggles
the
my
tornadoes, you don't know what storms will produce a tornado.
Do tornadoes
least-
happen in like Europe and stuff, or is this like I think you don't hear about them.
It's most common in the United States, but it does happen in other countries.
mind. Really?
And it's most common in the United States because of the geography of it.
Yeah.
You're getting all this different moist air, different winds. You can have any size tornado pretty much anywhere, but besides tornadoes, I'm sorry, I didn't hear that correct. But besides tornadoes, weather phenomenon that are still unsolved, you don't know exactly where thunderstorms will pop up. You can't know exactly. You can't predict you can't even predict 2 hours ahead. Oh, there's going to be thunderstorm here
That's
in an exact
crazy.
spot. You can say a general area will likely to see thunderstorms, but you don't know where individual cells will pop up. That's a lot of variables. That's still unsolved.
The rarest
Like
of storms.
Super rare that you could be
Super
able to-
rare.
Some rare shit.
Yeah.
I can't really think of anything off the top of my head right now.
What wins in a fight? Sorry. Fire tornado, water spout.
There's no such thing as a fire tornado.
There's not?
No.
What?
I think
man.
I've seen pictures before.
Damn
Look-
it.
Look that up right now.
I'm sure people have created them in labs, but I'm pretty sure there's
I-
not
Okay,
ever
actually,
been a natural fire tornado.
I'm going to
Yeah.
revoke my opinion. I'm glad there's no fire tornadoes.
Oh God!
Just
If there was a fire
California
tornado,
would be fucked.
Oh my
yeah.
god.
Fire tornado. Fuck you. I'm the weatherman now.
footage of a
It's not really tornado. It's like whirling flames. Whirling holy. That is horrifying.
That.
I don't.
that's
That
just-
can't be real. That
that's just
doesn't look
Mordor.
real to me.
Yeah.
That's more of a vortex from a wildfire, though.
Yeah,
That
tho-
looks
those
like
are
a
not
dry
tornado.
lightning.
That's
strike
what I
to
was.
me. Oh my good.
Oh god.
There's no way that's real.
I don't think that's real.
Yeah.
I've never personally seen a fire tornado, but
When you're out, when you're doing it, just throw out some napalm.
probably. I mean, I'm guessing. Oh.
This
All
is
right.
CBS, all right.
Well, okay. If
I'm
we
sure
do
it's
have a
super
fire
rare.
tornado and a water tornado,
How?
then it
Our water
probably
tornado is a
be-
thing.
Oh, water spouts, yeah.
Okay.
Water spouts
Oh.
are a thing. It's just a funnel cloud moving over
Yeah,
an
figured.
area of water.
Oh, okay. Okay.
Water spout, I would assume would win because water kills fire. So
It's true.
Wait,
Obviously.
Okay.
But then rock tornado. No, I'm just kidding.
no, that wouldn't happen unless you get a tornado so strong that it just
Tears through a mountain.
oh
like,
god.
lifts a whole mountain up,
Oh my
which
god.
would never happen
Yeah, that'd
because
be
that would be
horrifying.
impossible.
Yeah.
absolutely
That's when the
impossible.
world ends.
Yeah, that's when the world ends.
Wait. So, stupid question. Tornadoes can they move over? They can move over water. Oh,
Half these questions have been stupid. It's okay.
dude, I thought I was
We're
safe.
your- we're
I
the-
thought I was
But
safe.
they're technically called water spouts when they're
Yeah.
over water.
Okay.
Yeah.
We're the Labron guys, so
I thought we were safe because we have hills and a river.
we got
Neither of those
the
mean
river,
anything.
The river doesn't mean the river especially doesn't mean anything.
It's
The
tiny.
the hills could mean something because you're adding friction, which will
Yeah.
weaken it. But rivers don't mean anything.
Oh man.
In
River
fact,
don't mean
it's
shit to a
weakening.
tornado.
It's weakening the friction, so you have strong. You just have
Oh,
if a tornado moved like right along the Ohio River, you got no friction going on.
Oh
So you're
my
just getting
God.
straight inflow into that thing.
You know, every time we bring on a guest, I feel like I'm safe from things.
I
But
mean,
then
they never
just,
are.
They just tell me
It's just more and more
possible.
terrifying. Yeah, they're like, surprise.
There's a water spout.
You're wrong.
Awesome.
Yeah.
That's
And
terrifying.
those actually, you could get really weak water spouts too. Water spouts are actually pretty common. That's probably a strong one right there. That's a really strong one right there.
Wow.
But
What is that circle even trying to?
I am not sure.
It's like going. What
Is that thing? Is that
Are-
real?
Are tornadoes
Yes.
not just like one single like funnel up and down?
No, they can be sideways. They can go in all different shapes anytime. Yeah. All different shapes. Yeah. There's called wedge tornadoes, which are the big ones you always see on TV.
Yeah.
Yeah.
Then there's the rope tornadoes, which are the
Bending
really
boys.
twisty ones.
They
twisty
could like
ones.
twist around.
Oh yeah,
Oh
definitely.
my
I mean,
God.
There was
Yeah,
one
yeah.
the Weather Channel capsule. This was really cool. The I don't know, Brendan, could you look this up in there?
That's
The Weather
nuts.
Channel captured this is in 2009, a tornado in Wyoming, and the axis of it tilted so you could see into the top of it. And that had been the coolest thing I've ever
What?
seen. Yeah, the funnel axis actually tilted. I believe this is it. Oh, ad from someone who doesn't sponsor us. Yay. But
We get no
no,
money.
this was that was the coolest thing. If you could skip ahead past this. Right there.
What?
Right there. No. Go. Yeah, right there. That's it.
Oh my God.
Oh my.
Oh, I'm so scared.
It's just coming right for you.
It's like looking to me.
Oh
Yeah,
my.
and then it dissipated right after that.
Oh my
That
God.
is so cool. And
It
that
was
guy was
the-
really handsome. Congratulations.
He actually got hit by a tornado in 2013. fun
Oh.
fact.
Like
Yeah.
hit by like. What do you
The-
mean?
A really strong tornado. So what happened, there was this tornado in El Reno, Oklahoma in 2013, and it made this left turn, which is it's a really weird left turn that nobody really expects to ever happen.
Yeah.
And they were driving because, they were doing coverage, and they were driving down the road, and they were trying to get out of the way. It just went right over them, and they all survived. Luckily, they
Oh
all
my
survived.
God.
There was a storm chasing team that did die, though.
Did they get picked up?
They got lofted. Their car got tossed like
oh my God.
a couple hundred yards. Yeah.
A couple
Don't
hundred
they-
in a
And
car?
it flipped. Yeah.
Don't-
You never should be in a car during a tornado. That's the worst place to be.
Sure,
During
just throws you,
car
right?
or mobile home. Never be in a tornado for
Oh,
or never be in a car for a
man.
tornado.
Don't they
in a
have
car or
like
mobile home.
reinforced cars though, in case like for the storm chasers?
Yeah.
Kind of.
The Tornado Intercept vehicle, which is a documentary filmmaker made.
I remember. Yeah, I remember.
Me and Brendan actually saw it. We went actually for his birthday, believe it or not.
It's his
when
birthday
Brendan-
today, by the way.
Yeah.
Comment happy
Happy birthday,
Happy
Brendan.
birthday
Dog.
to our executive producer.
Number
Birthday, we
20.
love you.
My lord. But anyway,
His parents are very nice, by the way.
Yes.
His mom
no.
threatened me with love and compassion.
No, but I think it was his 12th birthday. The dude who filmed this documentary came to the Science Center in Cleveland with the actual vehicle he was in, and we got to see it, and that had been the coolest thing ever. And he showed footage of like being an actual inside the tornado. Yeah.
Did it stay grounded?
Yeah, 'cause it was like a tank. I mean, this thing was like
You're not-
military
you're not-
grade. Yeah.
Oh.
Yeah, pull it up.
Pull up pictures.
There's that, and but these chasers didn't typically have. But even then,
Are you going to be doing that for your?
oh no, we're not. We're just gonna be in vans. The school can't afford a tip.
No, I'm not. Maybe not the
Yeah.
tank, but I'm saying like you'd be in cars chasing.
We're gonna be in vans chasing tornadoes. We're gonna have radars and all that, looking at the radar, seeing where we can
That's
go.
awesome.
Now, there's no guarantee we're gonna see a tornado.
Yeah.
Last year, when they went on the
But
trip,
you're
they
gonna
didn't
see a tornado.
I hope I get to see a tornado because I've actually never really seen a tornado. Is this the footage of it actually inside, Brendan? I see those
we're
power
hoping-
flashes on there. That's the tornado actually blowing up transformers.
Oh wow.
We're hoping this is the footage of him inside
the tornado. Yeah, not for broadcast. Rip.
Oh wow, is
All right,
that it?
So that's inflow. Yeah, that's the tornado is just a giant updraft, and that's just feeding the storm.
Oh my god.
That I don't think that's inside, but you're pretty darn close there.
Yeah.
Yeah.
That is nuts.
That is.
That's
oh,
it.
Oh my god.
You can't see anything.
It looks like a car wash.
Unbelievable. That has to be it.
Yeah. I mean, I don't know
my
anything else that could do that.
god.
Then you see him just pull out of a car wash real quick.
That's either it or they're punching the hail core. I'm not sure.
The
Hail
hail
core.
core.
The hail core. Yeah, that's where the strongest area of hail is in the supercell.
I think that should be like in Star Wars or something.
You never, when you're chasing, you should
Into
never,
the hail core.
never
That
go
is
in the hail core
terrifying.
Oh, if I'm in a tornado, I'll make sure to never be
No,
in the hail
if
core.
you're ever like near a supercell, never go through the hail core because that will.
How will I know when I'm in the hail core? Or
You're
how
getting
to-
baseball-sized hail coming down.
Baseball sized
Well,
hail.
it could get up to base. It could get up to. I think the largest hail is like as big as a CD.
Damn,
Yeah.
That's nuts.
And
it's going
but-
like 200 miles per hour.
yeah, because it's accelerating.
Those are
as it goes down.
cannonballs.
Yeah. So
Oh
never.
My god.
Now,
Oh
if you're going through like quarter-size hail, that's fine. But it can get really, especially out in the plains, it can get gigantic.
Yeah.
So you should never punch a core with your car unless you have like
Punch a
bulletproof
core.
windows because you'll just destroy your car.
So if
completely
they're
destroy your car.
so if you are like let's say in Kansas or something.
Yeah.
And
God
you see a
forbid.
tornado, yeah,
Yeah.
and you see a tornado like 30 feet away from you,
Mhm.
and you're in your car. What is the safest thing you can do then?
Safest thing you can do if you're in your car and there's nothing, you're in the middle of nowhere, Kansas, go south. Go south and west. Get away, get out of the path of the tornado and get away from it. Now, of course, if you're near populated area, find like a gas station, convenience store, or a restaurant, and just they will let you in, take you back, and take cover in there. And just find
Okay.
find a sturdy shelter. But if you're in the absolutely middle of nowhere and you got nowhere to go and it's like relatively close, get south as quickly as you can because you don't want to go north because that will take you right through the hail core and you'll just
Oh,
destroy your
God.
vehicle. Yeah,
Okay.
get
So
south.
do, do tornadoes tend to go north and then east?
Tornadoes. So what tornadoes do? You have the supercell structure. Brendan, could you pull up a picture of a supercell on the computer? Because I can analyze.
Ooh,
into
okay.
In-depth
Yeah,
Yeah,
analysis.
because I always
and
wondered that because they all
Yeah.
turn in one.
radar image. Yeah,
Do they all turn in one direction?
it's always counterclockwise.
Huh.
Counterclockwise Coriolis force. So low pressure always goes counterclockwise.
Okay.
Kind of side comment. Is it true that like southern hemisphere things twist differently?
Yes, that is
Really?
Why
exactly true.
is that?
Again, the Coriolis force, because the rotation of basically the curvature of the Earth makes winds go a certain way in each
Okay.
hemisphere.
Okay.
All right, so this
get
image of a supercell right here.
Oh boy.
That big purple area up there, that's the hail core. If you could circle, yeah, that right there. That's the hail core. That's where the strongest hail is going to be.
Oh.
Now, if you go down to that little, all right, see that right where your mouse is? That's where the tornado is.
Holy.
Okay.
That's where the tornado is. That's what's called a debris ball. That's a debris signature. That's the radar not picking up rain, but like picking up the debris. that
Oh
the
my
tornado-
It
god.
has so much debris. It's
Yeah.
picking up
That's
on
its
radar.
red.
The radar, yeah. The radar's picking up debris.
Holy shit.
And
That's terrible.
so when say you're in what are you doing, Brendan? Oh. Say you're in Kansas. Could you point the mouse like right in between? Oh my goodness, what's happening? Okay, can you point the mouse in between the hail core and the hook echo? A strong rotation signature is a hook echo. That's a hook echo. That means the storm is rotating. So if you move it a little to the right, yeah, right there. So say you're right there. You want to go east or move it further down a little bit and a little more to the right. Say you're right there.
Okay.
Just want to get south of that storm because
Hmm.
that storm, the way it's oriented, kind of this direction.
Huh.
Or camera's opposite. So it's oriented this direction. It's going to move this way. It's going to move off to the north and east. So you want to get south
Okay.
of that.
Huh.
Yeah. But if you're in a highly populated area, just find a place to take cover because you never want to be in a car in a tornado. You never want to try to outrun a tornado.
That's
either.
really interesting. Head south. That's probably the
Head south. Unless there's another storm down south, in which
god.
just go punch it east as fast as you can, pretty much.
You
Or
better know
again,
your directions too, people. So.
or again,
Yeah.
just find a place, find like a gas station or something, and just get there. Oh, multiple vortex tornadoes.
oh
that's
boy.
When you have a really strong one. You could pull up a video of this actually, and I could point this out too. If you're really strong tornado, pull up the Tuscaloosa one, Tuscaloosa tornado, on April 27th, 2011. This was part of the super outbreak.
Okay.
So when you get really strong tornadoes, you'll have little. Actually, pull up the El Reno 2013 one, Brendan, because that one you can see them really well.
I like that you know the dates.
You just got a catalog of all these tornadoes.
Every weather enthusiast actually knows these dates pretty well. So
Oh my
yeah,
God.
but you
I bet
get
there's
these.
some guy there. He's like, what about this specific date?
Yeah. When you get these really strong tornadoes, you'll have
Wow.
these little vortices in these. Right here, that picture. That's the bottom. So the picture on the right is the full tornado itself. And then looking deeper in, those are the multiple vortices rotating around the common axis. And the vortices are the really strong
wow.
parts.
So there's a
Yeah.
bunch of like mini tornadoes, basically.
Bunch of mini
Inside
tornadoes
of.
inside of the parent one.
Holy shit!
That's a really good one right there.
Oh my God.
It's just drilling into the earth.
Yeah. Yeah, that's a really good one right there. Yeah, that's probably the best image you could find. Right there.
It's wild to me that we kind of just go, yeah, that happens.
Yeah,
Yeah, definitely.
you can.
Death
We
wins.
have not been able to ever predict how a tornado becomes multiple.
mind-boggling.
That
Gotta be
is
time lapse or something.
that's got to be time. That is a time lapse. That's not a.
Dude,
Can you imagine that many tornadoes just in a line?
That would be impossible. There have been there have been one tornado over here and one tornado over here in the past. It actually happened in 2014.
Oh.
It was pretty fascinating. It was like they're called twin tornadoes. If you could look that up in there too. That was a pretty
Brendan
cool
worked
thing
today.
because one was dying out and the other one was just forming. And
Oh man.
same time, they were. It was a really cool image. It's not that one.
Wow. Dude.
Go look up twin tornadoes in there, and and you'll see one big one over here, and then a few miles over, one big one over here.
What happens if any two tornadoes like meet? You keep
There,
big,
that's a good one right there.
big two, like one big tornado, or they cancel each other out.
I'm not exactly sure. I think one tornado is the one that just formed will choke out all the inflow from the other one and just get the one that just formed will get stronger, and the one that was already there will be choked out of all of its
Okay.
inflow. And
Yeah.
Strong will survive.
Yeah.
Strong will survive.
That's nuts.
Wait. So wait. So tornadoes are just like Sith lords.
I guess in a way.
Zach doesn't know Star Wars very much, so he only knows Sith, baby.
Yeah, that's
It's
pretty
okay.
much it.
I appreciate the reference.
Yeah.
So what crazy weather does Europe get? Because we talked about like they get
Europe
some stuff
definitely
we
gets
do.
monsoons.
Mm.
Europe can see tornadoes. Last summer, Italy had a
Oh man.
tornado outbreak.
Hmm.
That was pretty cool to see. The most extreme weather they get though is in the mountains with all the snow. They can see
yeah.
a ton of snow up there. And even we see that here too. But I think the United States is really the most interesting country
We've got
comes
so
to
much
weather
crazy
because you
stuff.
have so many climates over
Yeah.
such a large area and just a wide spectrum of
We got all the good
what you
disaster
can
stuff.
get.
We got hurricanes.
exactly.
tornadoes.
Yeah, you get everything in the
We-
United States. And if
Droughts.
you're in the right part of the country, like Tennessee or Alabama, you'll just see everything.
Oh man.
You'll get hurricanes.
God hates the South.
You'll get snowstorms occasionally. You'll get hurricanes. You'll get
You got
tornadoes.
hillbillies.
Yeah, you'll see anything like Tennessee, Kentucky, Alabama.
Oh, wow. I don't know if it's lucky
pretty-
or unlucky to live
It's
in those
just-
states.
For a weather enthusiast, definitely lucky. But for someone who just wants to live their life, I would probably go out to California where it's
Well, you just-
sunny and 72 degrees every day.
and you get lucky to have some water every so often.
Yeah, that's true.
Everything
The
sucks.
funny thing about California is, though, they'll go through periods of like 5 years of drought.
Mhm.
Then they'll make up that drought in a week, and they'll just get like 40 inches of rain. This happened like in 2015. If you remember, they had that 5-year drought for the longest
Yeah, yeah.
time.
Yeah.
And then it only took a month to just rid most of the state of that drought. And they had like floods and landslides and stuff like that. California weather is weird and just crazy. And
It can't make up its mind.
oh no,
Water.
it's even crazier than Ohio.
Surprise.
It's crazy in Ohio in the sense of a long-term climatological standpoint, where weather in Ohio can change daily. California, one year it's like dry as hell, and the next year you just see nothing but rain in like the matter of a month.
Yeah.
You
It's
just
like
see
Game of Thrones.
low pressure out of low pressure out of low pressure after low pressure just coming through. It's nuts out in California.
All right.
Yeah.
I got to ask it.
Yeah.
When it's fall
Mm-hmm.
and you're in the Weather Channel, how often do you want to say that winter is coming?
How often? Oh, I love winter myself, so I mean, I would love to say it all the time.
He knows
but,
nothing of the White Walkers
It just all
and
depends
the giant
on.
spiders and the wildlings coming. He doesn't understand Game of Thrones references.
I don't watch Game of Thrones.
You know nothing. Nothing, Nick.
But it just all depends on when the cold air just wants to come down from Canada and further north. Yeah.
Okay.
So some winters you could, and it also depends on the temperature. Believe it or not, the temperature, how warm or cold the ocean waters are out near South America. When you have El Nino, you'll see zonal flow in that jet, which means you'll have much warmer temperatures in the northern half of the country. But the subtropical jet stream will be further south.
What's El Nino again?
El Nino is much warmer waters in the East Pacific. So when you see El Nino, you'll see zonal flow in the polar jet and the subtropical jet. The polar jet will be further north. Subtropical jet will be further south. And that will bring much cooler weather to the south and much rainier weather to the south and much warmer and drier weather to the north of the country. La Nina is the opposite. You'll see the polar jet, very meridional flow in both jets, and you'll see a much stormier pattern in the eastern United States. El Nino, you'll see a much stormier pattern in the western United States, which is why in 2015, when California was getting over that drought, we had a La Nina pretty much every year since like 2011, I want to say. From 2011, 2012, 2013, they had that drought. Then in 2015, we switched to El Nino. We had a really strong El Nino. The jet stream slammed right into California. The storm track was right into California. They got all that rain. Okay. So the west will see rainier. West and south will see rainier, cooler weather. North and east will see warmer and drier weather. And it's the opposite for La Nina. So you'll see typically cooler, wetter, stormier winters up in the northeast. And the southwest, you'll see drier, warmer temperatures. And the strongest winters we get here, like the snowiest and coldest winters we get here, is when we see neutral pattern. When the ocean just typically, from what I've seen at least, when the ocean just doesn't want to do anything, when it doesn't feel like being warmer or cooler, you'll get years like 2013 where Cleveland had like over 100 inches of snow at that just one year. Yeah.
Jesus.
It's just weird how it works out like that.
Man.
And it just happens. That's nuts. It's like everything's almost connected, but
we are with climate change. We are expected to see more El Ninos than La Ninas in neutral patterns.
Yeah.
We've been in a weak El Nino, not as strong as 2015 one was a record-breaking El Nino, but this one's been relatively weak. So we kind of didn't see much of anything. This winter was kind of average across much of Ohio.
Yeah.
Really?
So we didn't really know. But we could definitely see a lot more El Ninos with with climate change occurring. The world's not going to end in 12 years, though.
I didn't think so. I don't know why.
Thank God.
Yeah.
What would even
I like this world.
Yeah. What do people even like? It's like they think that was gonna happen. Oh, the floods are gonna come. We're all gonna die. Tornadoes are gonna fall from the sky every day. Like,
and again, we don't know how it's actually going to affect like tornadoes necessarily. We do know hurricanes will probably be more common.
Yeah.
Because warmer ocean temperatures, but we don't necessarily know
Rip East
how
Coast.
it's going to do. Yeah, East Coast and the Gulf Coast too. We don't necessarily know though how it's going to affect severe weather, as in thunderstorms and tornadoes, because it's all based on the jet stream.
Yeah.
And I said this earlier. The jet stream's
It's
gradient.
It's everything.
Driven by gradients,
Mhm.
and you need a strong jet stream to create more mid-latitude storms. My theory is I don't think we're gonna see as many tornadoes in the future.
Aw.
Other people say we're gonna see more tornadoes. We just don't know yet. There's no way to tell.
Not that I'm hating on tornadoes, but I prefer to be have less of them. You know.
I would rather have more tornadoes than hurricanes, though.
Why is that?
Because hurricanes just like 10 times worse.
It's.
I mean, I feel
it's
like they're bigger and probably
'Cause
have more damage. Right?
Tornadoes cause more damage to a specific area
Yeah.
than a hurricane would.
Okay.
But a hurricane causes damage over more of a broader scale. So it just all depends.
Okay.
Really.
Take your poison. You know.
Yeah.
Take your poison.
Yeah. Right.
Do you want a whole city destroyed, or basically, do you want a whole city destroyed, or would you rather have your house kind of wiped clean from its foundation?
Oh my God.
Yeah.
None of these sound good.
None.
And again, these are all extremes. These are not typically.
Yeah.
These are rare occasions where your house is going to be completely lifted off of its foundation, or a whole city is going to be destroyed from a hurricane. But it's definitely, when you get those really strong ones.
Do you think there's ever a way to like artificially disperse a tornado? Like maybe can we like send something into it to kind of like disrupt whatever's going on?
I don't think now, but I think definitely in the future they're going to be looking towards trying to control the weather. I mean, if you can simulate a tornado on a computer, I'm pretty sure we're getting close to being able to figure out how to basically stop horrible natural disaster. I don't think it's going to be any time in the near future, but definitely
we're definitely thinking about it. Probably.
I would imagine probably maybe our children's generation or the next generation after that, we'd be able to
That'd
figure
be pretty
that
awesome.
out. Yeah.
That'd be nice. They got thunder guns and then just like boom.
It's like Sharknado when he shoots the bomb and the tornado dissipates. By the way, don't try that. It'll probably just cause more destruction. Anyway.
Someone threw a bunch of grenades into the tornado.
Wait, is that how they did it in that movie?
Yeah.
They ended
In
the
the first
tornado.
Sharknado.
How accurate is Sharknado, by the way?
Not accurate.
Is it the sharks that's not accurate, or is it?
Well, first of all, a hurricane would never affect California because unless you get like really everything comes into play.
Percentage of possibility.
Here's a backstory. So our freshman year of high school, me and my friend Joey had to take a public speaking class where we had to write speeches and stuff.
All right.
And so the first speech we did, he was able to, or not he, but we were all able to pick the topic we wanted to pick. And Joey, if you ever get to meet Joey's a great dude, but
nice job, Joey.
He's a character, to say the least. So his speech was going to be on the percentage chance of a Sharknado happening. So, of course, he knew I was such a weather nerd, and he asked me, Nick, could you help me on this speech? I'm like, sure, why not? So I figured, well, we need a specific type of shark that swim in shallow waters. We need a really strong EF5 tornado to lift the sharks out of the waters. And we'd, of course, so we looked at where the patterns of sharks online. We found that nurse sharks were the only sharks that swim in shallow waters. They swim in the Gulf Coast region.
Yeah.
So then we looked at tornadoes, since like the amount of tornadoes and the strength of the tornadoes in each state and the Gulf Coast since 1950. And we found that Texas had the most EF5 tornadoes since 1950.
Okay.
So we did all the math, and Joey came up with a 0.00007% chance of a Sharknado.
So you're telling me there's a chance?
Some small percentage. I don't even think that would be even close. But no, Sharknado is not accurate. First of all,
would that just kill the sharks? I feel like.
Well, yeah, it would kill the sharks because they're out of water. And they can't breathe out of water.
And they're slapping into things.
And all the other debris just. Yeah.
So
plus,
it would just really just be a shark like massacre. It wouldn't even be like
you just see sharks falling out of a really strong tornado.
Just
pretty
shark
much.
chunks flying everywhere.
Yeah, pretty much. And
however,
the movie Sharknado is not accurate because one, throwing a grenade into a tornado does not dissipate a tornado. It doesn't destroy the updraft. In fact, it would probably enhance the updraft because it would make air warmer in it, and that would make the updraft more volatile. Number 2, a hurricane's never going to affect California unless everything really comes into play at the exact right time. And number 3, you don't get EF5 tornadoes in hurricanes, so you're never going to have a hurricane strong enough to lift a shark out of the water.
Damn it. I feel like the worst case scenario would be an octopus tornado. Ocnado.
Oh, Ocnado.
Because imagine this. A bunch of octopus not only just run around slapping motherfuckers, they got 8 legs, and they've got suction cups. They're grabbing on everything. It's just that tornado just getting massive. They're just grabbing everything, and everyone's going to die.
I still like the picture in my head of some small town on the brink of Texas just having like sharks plop on the street.
Some small town like on the Gulf Coast of Texas. Just like this coastal town, everyone's on spring break, and all of a sudden
just sharks start flying out of the
shark
sky.
chunks are flying out of the sky, and it's all nuts and everything. Yeah.
There was a thing. Oops, sorry. There was a thing I saw. It was like frogs falling from the sky. Is that a thing? Have you heard of
that? Had happened before
or something.
I'm not exactly sure why it happened. I think they had a don't quote me on this, but I think they had a drought for so long that the lifting was so strong to like lift frogs. Now, of course, I don't know if this is even true or not.
Your best guess.
My best guess would be that, but honestly, chances of that would be close to impossible too. So I wouldn't say. If
there's a frognado, there's a chance of an ocnado.
Well, if there's a frognado, could definitely happen because actually frognado, there's a really good chance of a frognado happening because if you get you get bullfrogs living in the southern United States. It only takes a small tornado to lift a frog. So
I can lift a frog. I mean, shit.
80 mile an hour winds going up. Yeah, that could lift
I think
a
that's
frog.
the one plague that didn't make it through.
Frognado.
A tornado of frogs.
Now, if you get like a concentrated area of frogs in one place, I'm sure you can just see
frog
frogs
mating season.
Ribbit, coming out of the sky.
I'd be so pissed.
If there's a future storm chaser watching this,
find the frognado.
Just get, or you could make it yourself. Just run out in the middle of a tornado
just
path.
go to a zoo exhibit. Just grab all the frogs and just dump them in the path of a tornado, and then it just sucks up all the frogs. And
a supervillain's gonna do this. He's gonna get a bunch of sharks. He's gonna get sharks with freaking laser beams attached to their heads.
And we shall put them in the tornado.
And he just throws hundreds of them in, just like. That'd be a really dedicated evil scientist. I feel like, and it's such a waste of time.
It's such a waste of time.
You know.
Well,
it's a stupid shit.
I think it's
we've been talking a long
about
time.
that time.
It's been about an hour.
About them, if not over.
In conclusion, Frognado is a thing.
2 hours. Wow. Time flies when you're talking about weather.
Yeah.
Frognado is a thing.
It's the jet streams.
Tornadoes are terrifying.
Jet stream
also
is God.
really cool.
Yeah, the jet stream.
Praise the jet stream.
If you ever learned anything from this, the jet stream is the main driving force behind weather you see.
AKA Zeus. Zeus is behind weather.
Also, fire-nados aren't real.
Yeah, I've never seen it personally, but I guess they exist. Thanks to our lovely executive producer, Brendan.
Thank you.
Thank you, Brendan, for finding fire tornado footage on CBS.
Well, it's been great to have you on the show.
Yeah, thanks for having me.
Thanks for coming on. We appreciate it.
Yeah.
And thanks for watching. Make sure to subscribe.
Yeah. And we'll see you guys next time.
Bye.